All right, so we are in 7.6, I think. 7.6. Yes, sorry, ready for more. And it says right here, solve the following equation for theta on the interval from 0 to 2 pi. So I'm going to solve this equation on the interval from 0 to 2 pi. So whenever they say on 0 to 2 pi, that means I'm not going to add all those extra 2 pi k's or 2 pi n's, whatever variable you like. I like n, but for some reason our curriculum has 2 pi k, so we're going to go with 2 pi k. But here again, because they specifically state this um, from 0 to 2 pi, we're only looking at that first circle, so you don't need to add rotations, right? A full rotation. So my answer is just going to be straight in the first circle. So this seems really intimidating at first. I'm going to be honest. Whenever I see these, I'm like, ah. But then I just break it down to what can I do with this thing? So the thing that goes through my brain when I see this is like, I have cosine and I have tangent. So my first tactic for this one is, because I don't have a single trig function, I want to get everybody in terms of sine and cosine. That's my first tactic. Okay. So if I get everybody in terms of sine and cosine, maybe they will play better together and I'll see something that could work. Okay. So with that being said, I'm going to change that tan 3 theta into sine over cosine. So I'm going to use the identity that tan theta equals to sine theta over cosine theta. Now you're saying, but Miss Johnson, that's 3 theta. Good. So that would be tan 3 theta equals to sine 3 theta over cosine 3 theta. He just comes along for the ride. Does that make sense? All right, so that's gonna go right here. So let me put that in. So this is gonna be sine 3 theta over cosine 3 theta times cosine 3 theta. Okay. And that's still going to be equal to root 3 over 2. Okay, take a step back and look at that. Do you see anything? Do you see anything that you're like, ooh, that's helpful? Yeah, and you're like, ooh, yes, we can divide out the cosine 3 thetas. And you're right. So we're going to divide cosine 3 theta divided by cosine 3 theta. That is equal to 1. 1 times sine 3 theta is just that sine 3 theta, right? Now, in a previous video that I just did, I said something like, you can never divide by a variable. And when I say that, I mean to like when you're solving, you can't divide, like you can't just divide out to get rid of something. Does that make sense? Here we used an identity that had like a division of cosine 3 theta in it. So I'm not choosing to divide by cosine 3 theta. It's part of the identity. I hope that makes sense. I guess what I'm saying is I didn't come up with the idea to divide out. Okay. Okay, so then we go sine 3 theta equals to root 3 over 2. And at this point, if you're more comfortable with sine inverse, that's what you would do. I've been encouraging you all to draw out your picture. So here's where I would draw out my picture. And the sine is opposite over hypotenuse. And so sine is positive here. So this is root 3. This is 2. So I'm looking for 2. So this is this triangle, and some of you are like, oh, Miss Johnson, I know which triangle this is. This is 30, 60, 90, and I'm very good. And because the opposite side is root 3, that means this angle in here is my pi over 3. Very good. And then you're going to ask yourself the famous question. What's the famous question? Where else is sine positive? Right? And then you're like, oh, it's also positive on this side in the upper 2 quadrants, right? So again, this is pi over 3, this is 2. So I'm looking for this angle here. And if you've been tracking with me, since I'm cutting my pi's up into sections of pi over 3, and I have a whole pi here, and then someone ate one of my slices, so now I have 2 pi over 3. So this guy right here is equal to, so this is, now we're going to move to here. This is 3 theta equals to pi over 3, and 3 theta equals to 2 pi over 3. Okay. And then I'm going to do something weird, and it's not going to make sense at first, but can you just follow me on this? Now, I am going to add 2 pi k in here. And then you said, hey, Ms. Johnson, I thought you told us not to. And I'll show you why I'm going to, and it'll make sense. Okay. And I want you to find the trend in why you would choose to do that. Okay. So then I'm going to divide by 3, 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 divide by 3. So therefore, theta equals to pi over 9 plus 2 pi over 3k, and 2 pi over 9 plus 2 pi over 3k. Okay, so let me just preface this with pi over 9 is like right here. So can you like imagine yourself dividing this one piece of pizza into 3 slices like that? And then this one as well, kind of, and then continue all the way through. If you think that your answers are only pi over 9, this guy is pi over 9, and 2 pi over 9, which would be this guy here. Do you see how much of the circle you have left to cover? Right? We have to cover that whole circle up with all of those pi over 9s. Does that make sense? So we want to make sure we get all of the ones that are true for this. Okay. So the way I'm going to do this is I'm going to continue this little line right here. And I'm going to rewrite 2 pi over 3 as something over 9 so that way I can add those things together. So this is pi over 9. He's still the same. And then I'm going to add, let's see, I multiply by 3. So that's 6 pi over 9 k. And then this one is 2 pi over 9 plus 6 pi over 9k. And you're asking, okay, what, Ms. Johnson, I still don't get why you added those 2 pi k's. Your original instructions were to have it find all the solutions in that first circle, right? So in this first circle, if any of these numbers are included in that first circle, I'm going to have to include them. So here's my total list. Okay, so theta equals to, so I'm going to like put all this together for you. So theta equals to pi over 9, right? Because that's this guy. Plus 2 pi, and 2 pi over 9. Actually, I'm going to make 2 lists because that might be better. I'll make the other list down here. And now I'm going to add 6 pi over 9 to that pi over 9 until I get away from my first circle. So pi over 9 plus 6 pi over 9 is 7 pi over 9. K. Oh, no, not K. Sorry. Not K. Okay, and then I'm going to add another 6 pi over 9 to that 7 pi over 9 to see if it's still within that first circle. So another 6 would be 13 pi over 9. And you're like, is that still the first circle, Miss Johnson? Yeah, because if I had 2 pizzas and I cut them up into 9 slices, right? How many slices would that be? 18. So as long as my numerator is under 18, I'm going to go for it. Okay. And then I'm going to add another 6 pi over 9 to it. That would be 19 pi over 9. And you're like, wait a second, Ms. Johnson, that's bigger than 2 pi. Good. So then I'm going to cross him out because he's not in that first circle. Does that make sense? Okay. I'm going to have you do the second one. So you're going to do this one right here. 2 pi over 9. And I want you to add your 6 pi over 9 until you go over. So go ahead and take a second to do that. Okay, now that you're back and you did these calculations on your own, what you're really doing is you're trying to find all the angles within that first rotation. So I'm going to add 6 pi over 9 to it. So I get 8 pi over 9, which is within the first half circle, so we're good. And then I'm going to add again. So I get 14 pi over 9. And so again, still within that first circle. And if you're wondering again, if I had 2 pizzas and I cut them up into 9 slices, I'd have 18 pieces. So the moment that I go over 18, I'm no longer within that first circle. Okay, so if I add again, I get 20 pi over 9, and that's bigger, so I'm not going to count them. Does that make sense? Very good. So I'm going to make a couple of statements. First, when it says 0 to 2 pi, please don't make the assumption you're not going to be including 2 pi k. Because once you divide out, you've now made your angle smaller. So now you can fit more pieces in your circle. Does that make sense? It's like you've taken your one slice of pizza that you have left and 2 more people walked in. You're like, shoot, let's divide this up so that everybody has a slice. Does that make sense? So because of that, you're trying to fit as many pieces in that first circle and finding all of your solutions by adding them all there. Here's your kind of like, should I just do this all the time, Miss Johnson? Yeah. Here's what you do. You do this all the time. And when it says 0 to 2 pi, you make your little list like we did here, and you cross out anybody who goes outside of the interval that you're being asked of. Does that make sense? That's kind of like your safety net. Does that make sense? Kind of like, I don't know if you remember when you would try to find the least common denominator for 2 fractions, you could find a common denominator by just multiplying the 2 numbers, right? So this is kind of like your safety net in terms of, okay, well, what, like, I'm not going to remember all this. Good. Don't. Just find all of them and then go back to the interval and say, okay, wait, did I answer your question? Did I solve the following equation for all thetas on the interval of 0 to 2 pi? Yes, I did. Right? So let's say that you put your answer, you said, okay, Ms. Johnson, I found my answer, and it's this guy right here, right? And then you go back to your answer and you're like, okay, did I do it? Did I find it on the interval of 0 to 2 pi? Oh, shoot, no, I didn't. I found it on the interval of forever. So then that's when you go back and that's when you start going, oh, okay, then that means I need to solve this. Okay. So think about the most confusing part about this. I think at first you may have thought like this is the confusing part because the equation looks really confusing. But then now that you're seeing this whole thing, you're like, individually, none of these parts are like overwhelmingly like, I don't understand what you're talking about. But putting it all together may be a huge process for you. So just be kind and be patient with yourself, because as you do these problems, this is like riding a bike or playing a game or learning something new. You get better as you go. Thank you for listening.